Hello guys, I'm Brad Johnson with Lavender Camps, and this is a video about flow control using LEGO Mindstorms EV3. Now, let's first open a project and talk a little about what flow control is. If you navigate down to the toolbar in the bottom and click on the orange one, you'll be given the 5 main flow control blocks in LEGO Mindstorms EV3's programming language. First, we have the start block, we have the wait block, we have the loop block, the switch block, and the loop interrupt. Also, there is the stop program block, but that's only used in very specific cases that won't be covered in this video. First, let's talk about the start block. If I click on the start block, I can place a second block into my field. What does this mean? Well, when the the EV3 runs a program, it traditionally will run in a set sequence. So if I tell it to steer or drive forward for a rotation, and then drive forward for a rotation, then I tell it to turn a little bit, and then I make it beep. Let's make it beep. I'm going to play a tone. So in normal execution, it will run starting from the start block, and it will move forward, turn right, and then it will beep. So what I'll do is I've connected my EV3 via Bluetooth, and I'll download and run. My robot will move forward, as we can see here. Oops. Alright, so what have we learned? The move rotations is directly tied. Alright, so as we could see, it moved from block to block and then made the sound. However, it doesn't have to do that. What we could do is have it start both the sound and move simultaneously. So by having two start blocks, both will start when the program executes. So it will both move forward and beep simultaneously. Now watch the colored bars above each unit as I execute the program. See, notice how both of these execute simultaneously before ending. Now, what is this called? This is called parallel programming. And in most cases, you won't need to use it. However, it can allow you to do some really interesting things. This can be better represented at any point in a program by branching off into 2 separate blocks. We don't even need the second start, but that's only useful to keep things from getting too complicated looking. So now this program will execute the same way. Now, there is a couple things to keep in mind when you do parallel programming. First off, what's going on in the top should not have the two branches should have minimal contact with one another. They should be operating two separate processes. If they're operating related functions, then the programming will get a bit more intricate, because finishing one could have, like, for example, if I told it to move and steer and to move forward at the same time, that is not going to work so well. It's going to try doing the same thing both at the same time, and it'll become confused, which it just did not perform either moving forward or turning right. It got confused. So it's just something to be careful of, but you can have certain interactions using other flow control methods with the branching. So now let's look at the second flow control block, the wait function. The wait function is very versatile. The wait function is capable of delaying a program branch. So for example, if I have it wait for 1 second here prior to doing a beep, it waits for a second prior to beeping, I can execute my program. 1. See how the program waits here for 1 second prior to advancing to the beep. This can be used to delay certain events and space out certain actions. Now, the wait block is fully featured. There's a large number of sensors you can interact with in order to control the flow of your program. So, for example, you can wait for any button press, any brick button press, and it even has an output, so you can use that button press elsewhere. Or you could simply, like elsewhere, as if you had some logic function afterwards, and you could build a complicated response based on what buttons were pressed. Or you can use compare functions for any number of things. This one will take us any set of buttons that can be pressed and check and see if they were either bumped or pressed or just released. So if I run this program now, it waited for me to press in the button prior to starting. But if I run with a bump, I had to press and then release prior to running. And this can apply both for the motor, for the touch sensor, as well as similar concepts can be applied for any of the sensors. And not to mention, the wait block can be useful when you're doing parallel programming, but I'll let you try and figure out how that can be used. Now let's move on to one of the most important blocks in programming, the loop block. The loop block allows you to execute a number of a group of actions over and over and over again until certain conditions are met. By default, the loop is set to unlimited, but you can have it run for a certain execution, certain time. You can have it wait for a logic input if you wanted to have a more complicated logical response than any one of the individual sensor compares. You can use a count-based trigger, so you can make it stop after, let's say, 5 counts. Interesting fact, this wire here actually will carry the value of the loop count. So if you wanted to adjust indices in array or make something operate based on how many times this loop is executed, this wire will do it. Another thing worth mentioning is this up here. This is the loop name, and this is important when you're dealing with interrupts, which is something we'll get to a little later in the video. So we have a loop, and what can we do with it? First off, let's just do a basic state comparison with a bump sensor. Or a press. So this is gonna demo, let's say we have our robot moving forward. This is gonna have the robot move forward one rotation, then compare to see if the bump sensor, the touch sensor has been pressed in, and then it will loop back around. So if I execute the program, you can see the lines looking at the move, then it flashes at the compare. And until I press the sensor, the loop will break and it ends. Another important concept is you can just turn on the motor. Jack will cover this a little bit more in his video on motor control, but this will prevent the motor from stopping after each time. It will move continuously until this condition is broken. So now we understand loops. You can do even more complicated things by putting loops within loops. So you can have this operation perform and then have a separate set of behaviors that will only occur after the sensor is touched. The behaviors will occur and then it will loop back and then restart the initial loop. So as you can see, things will get can get very complicated very fast, but at the same time you can do some really cool things. Now let's look at the fourth operation, which is the switch, or a switch case. So the switch case will have two separate views. You can either do the flat view, which allows you to select cases by the tab up top, or you can switch to the water view, which will show both tracks. Now the switch case will behave in two or more different ways. So for this case, it's looking at a Boolean comparison, so we'll either have true or false. So we're looking at to see if the sensor was pressed. So if the touch sensor was pressed, this top portion will run. If the touch sensor is not pressed, this bottom portion will run. So to demo, I'll have it play a sound in the event I touch its sensor. So let's have this run in a loop here. Oops. Let's have it run in a loop so I know that it's going to check the touch sensor when my finger's on it. So if I execute the program, alright, you can see that the blocks for this outer loop and the inner switch case are flowing. That means it's constantly checking and then looping back. However, the moment I touch the touch sensor, it triggers the sound up here. So as you can see, it can clearly activate a separate rail based on whether the sensor has been activated, and it can keep looping back and checking it. However, what else can this do? Well, another thing we can look at is there we go. we're going to look at an ultrasonic sensor. This is still in a comparison type. Let's still look at a comparison. However, alright, this has got a threshold. Can I change this over here? Oh, here we go. Numeric. There we go. So, what you can do that's really interesting is if you switch to tab view here, and you have numeric, you can program a large number of responses. You can just keep adding cases. So you can do switch case, switch case, switch case. And as you could see, something such as the something such as the touch sensor here has a state output, and that state is, there's 3 different states. So it has both the we have both the change in state. Grr. See the state right here? The state is numeric. That means that this will output the numeric state for this case. So we could program potentially 3 different responses, 0, 1, 2, based on whether or not it is pressed, bumped, or released. So you could do some interesting things with that. Additionally, you can have more complicated logic. You can remove these. You can have more complicated logic response to trigger between the 2 of them. And you can even put switch cases within switch cases, so you can program even more complicated responses. If true for this one, then you can check an additional case and route based on that. Another really useful tool is the compare, or the range compare. So this will output a Boolean based on whether or not it'll output a Boolean based on whether or not something's within or outside of the desired range. And this can help make more. This can help you with using sensors such as the ultrasonic sensor, or you can use the ultrasonic sensor or the anything dealing with proximity, so the sound or a actual value. So you could deal with, again, ultrasonic sensor, you can deal with sound sensor, or you could even deal with a timer, or you could deal with rotation, anything that has to give more of an analog value, not just a 1 or a 0, or true or a false. You can use the range to specify certain bounds. So if the event here is I have a test value, so if I had a ultrasonic sensor block here and I output its value, so the ultrasonic sensor block will behave, it'll read the ultrasonic sensor, and however far something is away, will go into this block. It'll then compare to see if it's inside 25 to 75 centimeters. And if that's true, we're going to have a beep. But if it's false, nothing will happen. So I'll execute my program. As you can see, it's, for lack of a better word, it's immediately reading, comparing, going false, and then looping back. However, if I actually hook up my ultrasonic sensor to port 1, you'll find that it now will beep as I back up to be 25 to 75 centimeters away. But when I get close, it won't beep. So that, that's in a nutshell, is one of the best ways you can use a switch case to deal with a more analog response, such as a distance. Now, there's one final thing I want to tackle before we're done here, and that is called the loop interrupt block. And this is perhaps one of the most complicated things in the language. Interrupts are kind of just break all code, and you can use them to break out of loops for whatever reason moves you. So just a really good idea on how to use it is to have an interrupt usually running. It can either be within a program, such as I can actually have this at the tail end here, and then have an interrupt here. Notice how the loop's name, let's name it loop, has to match the ID of the interrupt. So now loop and the interrupt loop. There's only one option, and it's the interrupt whatever the designated loop is. So now if I run this program, it'll continuously be running until I back up, and then it will break the loop, which is an unlimited loop. The loop should not stop ever, except when it's interrupted, and then it plays the tone and ends the program. One more possibility is with an interrupt is to have it running parallel to a loop. So on another section of the code it could be executing, and you could break out of whatever the loop is and then either move on or terminate the program based on some response. So let's say I want to break the program whenever a button is pressed on the NXT. So if I execute my program now, it will again perform the same ultrasonic check, and when I back up it triggers a response. However, if I press a button, it kills the entire program. So I press the brick button, the loop interrupts this, and then there's no code left for it to run. To get a little bit more of an idea how you could use a loop interrupt in a more complicated program, I'm going to show a bit of code that I wrote. So the program that's loading is going to, this will perform, how do I describe it? This is for a moving robot, and the robot will wait for, it'll move and it'll do a dance or whatever. I think it's going to move forward here. Yep, we have a loop name forward. And what's going to happen is, it's once either the top touch sensor, or sorry, there's two touch sensors, a top and a right and a left sensor. And what's going to happen is these loops here will run and wait for either sensor to be hit. And once one of the sensors is hit, it will break the forward loop. It'll run through a logic check loop. And what this is going to do here is going to wait for all these to execute. So this is going to move the stop the robot, move it backwards, cause it to turn, beep, and then set the ready variable to be true, which will allow the program to move on, which will then reset ready to false, and then begin the forward loop again. So that's just a bit of an idea how you'd run an interrupt in parallel. Okay, so one last thing I want to cover is the MyBlock concept. If you're familiar with programming, I'm sure you're aware that there's something called a function. And a function is a piece of repeatable code, so you write it once and it will be used multiple times in a program, and it can be used to simplify how something looks. It can take a variety of inputs as well as outputs that change its response. And the EV3 software has a similar concept to that. So the MyBlock, unfortunately, there's one issue with it. But the MyBlock, for all intents and purposes, acts like a function within EV3 software. So to start making a MyBlock, you're going to drag and select a group of blocks. In this case, I want to select both my range function and my switch case. So to do that, I just drag and click it, and then I'm going to go up to Tools, click on My Block Builder. Once you click on My Block Builder, you can customize the name, which I'm going to do range beep. You can type a description if you care about that, and then you can also edit the icon of the block, and I'm going to put the range icon there. Additionally, you can set parameters for the block. So I'm going to add 3 parameters to my block. Now, to check each parameter, you can shift them left and right. But to check the parameter, you're going to go to Parameter Setup. And my first parameter to name is going to be distance. I agree. Or analog value. And we can, we're going to set it as a vertical or horizontal slider, and it's going to be 0 to 100 with a default value of 50. So as we can see, this is clearly a number value. And by default, if you're using a slider, that's going to be the case. And for parameter icon, you can choose whatever you want. So let's say I'm just going to make this be X for distance. And then you can go and click, we're going to click the next parameter. The next parameter is going to be the lower bound. So for the lower bound, let's copy the icon, or if I can find, I can't find it. So lower bound is going to be for A, and then our upper bound is going to be B. And you can even have outputs, so you can designate one as an output or input. As far as outputs go, I don't think our function here is going to have one, but we could. If the function has some kind of output, a number or Boolean value, if it does math, you would have an output, and then it would behave similarly to an input. So let's name the second one to be upper limit and then the bottom one is going to be lower limit, and default is going to be 25, and then this one's default is going to be 75. So with that, we can finish our MyBlock builder, and as you can see, you're presented with a set of blocks which will have your inputs and outputs. Outputs would be on the right side, and you drag, let's say this was going to be output, you could drag this and you can just plug it in the output, and then you'd have access out of it outside of the range beep my block. So I want A and B to be connected. So I'm going to drag their wires around and hook them up. So now it receives 3 inputs and then it executes the code. So with that, I'm going to save it. Oops, that's the whole thing. Cancel. I'm going to go back to my program. As we see, the blocks of code that I had highlighted, it's now replaced it with a range beep my block, and as you can see, it has the default parameters that I inputted, which I could change based on these could be variables from other points in the program, or I could use the loop counter. This would also allow me to easily switch what sensor this is using. So now I can get rid of my ultrasonic sensor and pick this back up. Ultrasonic sensor, I can get rid of that. Instead, I can use something, let's say my sound sensor. And now the decibel level, which is a ratio between, it's a number between 0 and 100, is now once again going in, and it'll behave the same way as if it was the ultrasonic sensor. And that covers the basics about using a my block. And with that, I believe I've covered everything I want to about the basics using flow control with LEGO Mindstorms. I'll talk to you again later in another video. Take care.